A very good evening to one and all. This is SS Navalgund presenting a talk on scientific computing using Python. First of all, I would like to acknowledge the support by Institution of Engineers India, Dharwad Local Center, the chairman Dr. R.L. Chakrasali sir, the secretary Shri Vijay Totgir sir, and all the executive committee members along with office bearers and participants for making this talk happen. Thanks are also due to SDM management, principal sir, HOD madam, and faculty and staff of the college. This is a brief set of references that I have gone through for preparing for this talk. The table of contents are as shown here. We start with the basics of Python, look at very brief data types and structures, flow control, and how to plot with the Pylab, and a brief introduction to Numpy, SciPy, and then the summary. Well, if one has to look at Python, this is what we remember. Depending on what part of body of the elephant you touch, you are going to describe it as a one. So Python is like a giant. It has many aspects. It can be used for web development, graphical user interface development, scientific and numerical computing, software development, system administration, and so on. In this talk, I'm going to focus on those features of Python which are used for scientific and numerical computing. If you look at the basics of Python, the first thing that comes to our mind is Python implies a snake, a giant snake. But please note, the right-hand side picture corresponds to the inventor of this language, Mr. Guido van Rossum. Since he was a big fan of a 1969 British comedy show by the name Monty Python is just like a name of any person. So he thought of naming the language after his favorite comedy show, and he called it Python. This is the cast and crew of the famous serial back then and now. So Python has nothing to do with the snake per se. It is a very powerful general purpose programming language devised by Guido van Rossum in 1989. It is basically a higher level language, much more expressive than C because of its syntax. It has a very rich variety of original data structures such as lists, tuples, sets, and dictionaries, which make this language stand out and perform better. Just to give an idea of how much powerful this language is, this is an example of outputting the names of three famous personalities in the human history: Sir Isaac Newton, Marie Curie, and Albert Einstein. This is how I need to write a simple C program. I should declare variables, include all the relevant header files, make use of the functions, use for loop, and then display the output. Well, come to Python. It just takes only 3 lines. The first 2 lines are comments. So a program as big as this gets reduced to just this. That's the power of Python. In terms of advantages, it has a lot we need to offer. The Python language has a very clean and simple syntax to understand. It is first of all free, and it can provide cross-platform support. That means you can develop applications for a different platform on a platform that you already have with you. It supports a large library of modules and packages. To name a few, we have Numpy, SciPy, Matplotlib for data visualization, numerical computing, and so on. It is very simple to learn. The learning curve is very sharp for anybody who wishes to learn this particular language. It supports multi-paradigm language also. In terms of disadvantages, the speed is the biggest bottleneck. Since it is an interpreted language, the program gets executed line by line, and hence it is slightly slower when compared to C or C++. But it makes up for this loss in terms of the ease of developing applications. It's very hard to hide or obfuscate the source code. Because of its expressive syntax, you cannot write a program which is very tough for anybody else to understand. Of course, there are a couple of compatibility issues between Python 2 and Python 3 version, Python 3 being the latest one. Let's have a very quick look at data types. Integers, floating point numbers, and complex numbers are supported in a big way. The best part about integers is you can always declare an integer as huge as you want, as big as you want. Floating point numbers appear like the one shown over here, and complex numbers can also be manipulated very easily. If you want to manipulate complex numbers in any other language, you need to write explicit functions for this, but in Python, it just gets done. Python can be also used as a calculator. Its shell can be employed to make use of arithmetic operators like addition, subtraction, multiplication, division, exponentiation, so on and so forth. It also supports a very rich set of math functions. If you want to find the absolute value of a number, just say ABS followed by the argument. It returns the value. Now this corresponds to the command prompt of the Python shell. Now, if you want to find the absolute value of a complex number, we need to say ABS followed by 3 plus 4j. So the answer is going to be returned as 5.0. So for different types of input operands, be it a float number, integer, or complex number, we get the output. The biggest advantage of going for this is the variable declaration. Well, in C or C++, you need to declare the variables, but here there is no need because it's a dynamically typed language. Then you can ask a question like how the variables are understood to be integers or floating point numbers or characters or strings, so on and so forth. The technique used by Python is called duck typing. What does that mean? Let me give an example. On the lighter side, if you need to identify a bird as a duck, how would you go? Well, the answer is simple. You observe the bird, and if the bird walks like a duck, quacks like a duck, and swims like a duck, then you say that the bird must be a duck. Funny, isn't it? I repeat once again. If you look at a bird, and if the bird walks like a duck, quacks like a duck, and swims like a duck, then the bird must be a duck. That means, in the context of Python, if there is no decimal point, then if the number appears like an integer, it is assumed to be an integer. In the presence of a decimal point as shown here, if it resembles a floating point number, then it must be a float. So this is the dynamically typed technique that Python uses. The entire show is managed with the help of just 29 keywords or reserved words as shown on the slide here. These are the different Python objects like lists, tuples, dictionaries, and sets, and these are the syntax part of it. Let us not get into the details of these syntax part. Python also provides a rich set of repetitive statements. We have a for loop with the statements written like this. It's very easy to navigate through different strings and manipulate them easily using a for loop. We also have a while loop where until some condition is true, the sequence of steps they are repeated. We also have a do while loop. Python also supports control flow statements like if else, if, elif, else, so on and so forth. Now this is the syntax of the language. Surprisingly, there is no any switch case statement as in C and C++. In fact, it is also possible for us to plot simple waveforms using Pylab. What is this Pylab? Please note, matplotlib is a library which gives us flexibility to go for data visualization. That means for plotting purposes. Pylab is called a package which is similar to MATLAB, and this is predominantly used for plotting of different functions. You just have to say import Pylab and get going. The red colored lines indicate a simple program where AX is the given input dataset, AY is the given output dataset, and we just have to say pylab.plot AX, AY. So X gets plotted versus Y, and then we show the graphs. Another interesting feature provided is called multiple axis. That means we always know X versus Y. But if there is a third variable also, how do we manage it? That is called multiple axis. In this example, the x-axis corresponds to the years, the y-axis corresponds to, let's say, the rate of dose per 1,000 people. That's the argument we have, that's the data we have. And The amount of or pound of margarine per capita consumed. Well, people have done a very interesting study and they have found that there is some kind of relationship between the amount of margarine that people consume. It comprises of a type of sweet type of sweet that people consume in the US, and the divorce rate in a particular place called Maine. So if there are multiple input and output values that are to be matched, then they can be done very easily with the help of multiple access facility available in Pylab. Let's look at Numpy. Numpy is basically a de facto standard package for general scientific programming. That means, if you want to create a matrix, if you want to find the transpose of it, if you want to reshape it, if you want to sort a sequence of numbers, if you want to perform statistical analysis, if you want to go for any mathematical function, so on and so forth, Numpy can give you those flexibilities and facilities. In fact, Numpy also supports polynomials. If the polynomials are written like p of x and q of x as like this, the syntax is as follows here. You just have to write polynomial followed by the coefficients. The first polynomial p, the second polynomial q. Then the polynomial addition is as simple as saying print p plus q, polynomial subtraction, polynomial multiplication, division, so on and so forth. It's also possible for us to find the roots of a polynomial as easily as shown over here. We just have to say p dot roots. Along with this, all the calculus related functions are supported in terms of derivatives or integrals. Given a polynomial p, you just have to say print p dot deriv. Now this is a standard function, library function, which gives the first derivative. If you say p dot deriv followed by 2, it gets us the answer for second derivative of polynomial p, and it goes on. This example shows how Python can also be used to aid in solving electrical circuits. Given this circuit with certain values of resistances and voltage sources, once you are able to write the Kirchhoff's laws equations or KVL equations by performing mesh analysis, once you get this particular matrix form of representation, you can write a very simple program using Python to get the answer. So you'll be able to arrive at the values of current I1, I2, I3 as easy as this, as shown over here. Well, coming to the summary part of it, we have discussed about Python basics. We have seen the different language elements. We saw that the language element set is very small yet powerful. There is a very rich set of libraries, packages, and functions supported by Python. In fact, Python is being used in various fields like artificial intelligence, machine learning, and deep learning. All the big companies, IT companies, they also make use of Python in some form or the other in developing their algorithms, developing newer tools and techniques for the betterment of humankind. Thank you so much for listening to the talk. Thank you very much.